Hello everybody, this is Dhaval Kanadi and I am here to present a demonstration video of our project that is location based news classification using machine learning. Uh, Before we go to our project files, let me tell you our project is a web application, so we are using Jupyter Notebook for its execution. Okay, let's see our project files. So these are our main project files. Uh, Before that, let's check the code that fetches the data from the websites like hindustantimes.com, timesofindia.com, Indian Express, that provides news, as our project is based on news classification. So a list of cities contains Delhi, Mumbai, Pune, which are the three reference cities we are using for the illustration of the project. This allnews.csv is used to store all the data that is fetched from these websites. This a plus is used to append, so whatever data we are getting from this code will be stored inside this file allnews.csv. We'll check that later. Let's come to this code. So what this code does is it passes the links fetched from the reference link URL, that is hindustantimes.com. It fetches all the articles from that and passes it and breaks all the data. This code, that's where data R strip, L strip, basically breaks the data according to the city and store it in this file. So if we copy this link hindustantimes.com/topic/city, like whatever city name, here we are using plus city, which will be provided from this part. So for example, if we use Mumbai, it will show all the news from Mumbai itself. If we replace Mumbai by Pune, it will show all the news from Pune. So what this code does is it fetches all the links, all the articles, and stores it in this file. Before that, it parses it, it breaks it, and checks whether it is from the particular city, and then store it in this file accordingly. We'll check this file later on. So when we run this file, and this is the part that adds all the data we get from the links in this file. So when we run the code, like, it fetches all the articles from the respective cities. Like here it has fetched from Delhi, then Mumbai, then Pune, and so on. Because we are using only 3 cities, it is fetched for 3 cities. Likely here we are using Hindustan Times. Similarly, we are using the same code, just a different link or URL, you can say, as this Times of India. www.indiatimes.com/city. Even here you can check it like city, and if you type Mumbai, it will show articles from Mumbai. Similarly for Pune. So nothing's different from this code, this Hindustan Times code, and this timesofindia.com code. Just a small change, like instead of URL of Hindustan Times, we have Times of India, and this is where it differs. Like if we go to if we copy this link, paste it in our browser, type whatever city you want, it will show all the articles related to it. If you open the article and if you check inspect, it will show division and class of that respective article. So this would be different, only the URL part and class part would be different attributes, rest all the code stays same. So likely even this code will fetch for the cities, and similarly we are using it for Indian Express. uh, Before that I would like to tell you that this beautiful soup and the part here soup.find, what it does is it extracts all the data from HTML or XML file from that website and writes using this part in this file, allnews.csv. Let's check allnews.csv first. I'll show you that. So here are all the articles that are extracted from these websites. Here the column name is text, label, NP. So the text is whatever data that article has. Label is the location of the city or the city that user has chosen. NP is the name of newspaper, so it will arrange it like that. Okay, I'll show it in Excel form. So as in Excel, it looks like this. This is text, this is label for city, NP for HT, NP for newspaper, HT for Hindustan Times. Similarly, I for Indian Express, and TOI for Times of India. Here. So now we'll come to the part where our algorithm and its accuracy is checked. It is this file in real time. So this is the code. Here all the libraries that are required are downloaded. This code downloads all the required libraries. It consist accuracy score, TDF, TF-ID, vectorizer, naive Bayes, SVM. So these are the models, or you can say algorithms, that are used in this project. So precision score, recall score, F1 score, these are the performance metrics that are being used to compare all of these algorithms. Corpus equals to pd.read csv all news. So this is the file that is read in this line. The data from this would be used as test data and training data. So what this line does is it removes all the blank rows if any row is present inside. Then this part of the code will change all the text to lowercase because that is required to interpret as the capital or caps is interpreted differently in Python. Then third step is tokenization. So this converts the data into tokens or tokenizes it. Step T. So it removes all the step words. You can see in this presentation we have mentioned this data retrieval. This part was data retrieval and the second part was text preprocessing. This involves tokenizing of articles. So this part basically does tokenizing. So we run the code. All the libraries are downloaded. Then tokenized. So this number over here, text size 0.3, indicates that the data that we got from here, allnews.csv, would be splitted in the form of training data or trained data and test data. So this number suggests that 30% of the data is used for testing and 70% of data is used for training. Here this part training, this is basically splitting, and here the data is encoded. As you know that algorithm doesn't understand higher level language, like if it is a city name, suppose Delhi, Mumbai, Pune, so it won't get it if it's in alphabetical forms. It don't accept alphabets. So what this does is it converts any text into number in binary form, like suppose 0 for Delhi, 1 for Mumbai and 2 for Pune. So this is what it does. Then if we run this, this part of the code checks the accuracy of new Bayes algorithm. Similarly, this part of the code checks for precision, recall, and F1 score that is used for comparison and check the accuracy. Uh, this has its own formula, precision has its own formula, recall and F1 score has its own formula. I'll show it to you. So this is the formula for precision. If there is a multiple class, then this formula would be used. Similarly for recall, this formula, and for multiple classes, this formula. Similar from F measure or F1 score, this formula. So what it would do is it finds the accuracy of Naive Bayes algorithm. Then here is the confusion matrix. This code generates a confusion matrix. The confusion matrix is basically cities, uh, or you can say if there is a conflict between two cities. If suppose there is an article that has two cities names or more than two or more than one city name in it, and it conflicts, right? So this matrix shows that how many times those both city names comes in the same article or has come in the same article. So here the confusion matrix shows that here there's 13 times Delhi and Mumbai has conflicted. So 13 times, or the 13 articles where Delhi and Mumbai or Delhi or Pune has been mentioned. So here is a code for SVM classifier to check the accuracy. Similarly, precision, recall and F1 score, predictable label, and confusion matrix is generated. Similarly, for random forest classifier, these are the three algorithms we are using. So all three algorithms are checked for accuracy score, precision, recall and F1 score. Similarly, confusion matrix for this one. And in the end, this chart shows whichever algorithm is giving the best results for that particular set of data. That this might change for another data, but for this Naive Bayes seems best, then random forest, then SVM. Here SVM was run 2, or you can see it twice, and it shows results like this. It were consistent for both the time. So now it comes to the front end part. So for front end, I'll show it to you. For front end, we are using Flask. So here is Flask. It contains CSS, fonts, images, and videos. Then the templates have all the pages that I will be using as front end, like register, login, home, index. So when this Jupyter runs the server, this index.html file will be called. So So basically what it has is like simple login interface. Then this is where simple data connection and database connection is made. Here it is. Here you can see the password is checked. Login and registration is done over here. The flowchart in this PPT explains it really well. Over here at the on page, it will ask if user wants to log in or register. If it's already registered, then it will log in. If it's not registered, then it will ask the user to first log in. Pardon, it will ask user first to register, then log in. Then it will ask user to enter the credentials. If it is correct, then access would be provided. If it's not, then it would be reverted. Then user would be asked for location. Accordingly, it will be asked for the the newspaper you want to access. So this app basically checks that. And also here ht count, toy count on I count. What this does is it, it saves the count, the number of hits the user has done. This HT stands for Hindustan Times, TOI stands for Times of India. So what it does is basically count the number of times the user has hit a particular newspaper, or you can say source. What this line does is, not that, this line that will, once the user enters its location, this line will fetch all the articles related to that city or that location and display it to the user. We will know that when we see the GUI, or what we could say, the part that, or the web application that the end user would be using. So let's move on to that part.